I was in here a few days ago and I asked the exact same question. They said it, and then I disproved it, and then they.
But magnetism, right? Why would it be like different? Like affect different things differently, like based on their like how heavy they are or stuff like that, like how massive they are. Like how would magnetism change like the way if anything, like if you had more feathers, like aside from like less feathers, it should affect it less because the pull would be weaker.
And you get objects that are different kinds of magnetic, like ferromagnetic objects, which would, according to them, fall at a different rate, which doesn't make any sense.
Yeah, so I don't know if that would be their answer. DJ, are you there? I know DJ is like one of the people who like stays here like for a long time.
Hey, Subner Cross.
Hey DJ, how are you?
Good, man. How are you?
I'm good too. I'm here to ask you guys questions again.
Yeah, cool.
Do you have a minute? I would like to ask you a question. The same question I asked, I think before you joined. I don't know if you were here or not for that.
Yeah.
Which is in like not assuming any models, ignoring, because I'm not a flat earther, but ignoring that I'm not a flat earther. I just want to know, like, on the flat Earth side, do you guys have an explanation as to why things fall down?
Well, relative density would be the reason things go up or down, right? But no one knows like why there's two primary vectors, right? Up and down are the two primary vectors.
Yeah, well, we do know it's called gravity.
Yeah, so I would say no one's able to validate through scientific experiment, right, to prove why there's an up and down vector, but we can validate why things rise or sink, right, due to relative density.
No, yes, density. Yeah, density is a factor, right? Like the more dense, the less, the slowest it will fall, like a feather. Although that's different in a vacuum, but let's ignore that for now. Like we know that they fall at different speeds. Like if it's more dense, it falls at a different speed. But and some things, like for example, gases will go up even though they have a certain weight to them, right? Even though they have like a certain level of mass. So we know that there is like a force, and we know that there's a reason. Not even saying a force, but we know there's a reason why they go down, and we know they have to meet a certain threshold to go down, because if they are too light, they will float up, like helium, for example. Inside
or like the water cycle, for example. Yeah.
Mm-hmm. And we also know that there is a fixed speed as to how fast they will fall and how much they will accelerate, depending on where you drop those things from. So those things are measurable, right? They happen. And they are different. Depending on what
sort of, yeah. Like I would agree that things fall at roughly 9.8 meters per second squared, but it's not exact. It's different in different places, and it was an agreed upon average. Yeah, I mean, if you look at like things like the Bremen drop tower experiment, they have a bunch of different elements in the world's biggest vacuum chamber drop tower in Germany, and when they dropped them, some of the different elements did fall at different rates. Lead, for example, and yeah, so that's something to have a look into. What's that, sorry?
That's due to terminal velocity, no?
Well, it's just a giant vacuum chamber, right? It's called the Bremen drop tower, and all they're doing is they're dropping a whole bunch of things side by side in the drop tower, and they don't all fall at the exact same rate. Mm-hmm. But it's close, right? I mean, it is an agreed upon average, and I would agree that things do roughly fall at the same rate.
But my question about that, right? My question, the reason I'm asking you that question is because that is something that we can test, that speed, like roughly, it will always, like not always, but like roughly be around the same for everything, and it will accelerate based on that, like based on everything else. So I think it wouldn't be like that much of a stretch to based on that assume that there's something that is attracting something to the ground, like that the thing is like a certain weight will go down, and there's a reason why it goes down. Maybe I would just like to know what that reason is. So you say you're not aware, right? And
I don't think anyone can determine the cause of the effect. We all agree on the effect.
Fair enough. Like I
But
totally,
I mean, yeah, I also think that things don't just fall, right? They need some energy to be displaced in the first place, right? In one way or another, right? Some energy has to be
You have to lift
exchanged.
something up. Got to lift
Yeah,
something
nothing
up.
will
That's
just-
for sure.
Yeah,
Well,
in
yeah,
one way
yeah,
or another. Yeah.
they
Like,
actually,
okay, I think all things seek equilibrium, right? So if you've got a rock sitting on the ground, it's never going to move, right? Unless, for example, I come along and I exchange some of my energy, right,
Yeah,
to
fair enough.
displace the rock from equilibrium. But look, what this is going to come down to, like, we can validate through experimentation, you know, cause and effect relationship, why things go up or down, but why up and down? No one
basically,
knows. No one knows for sure.
basically, I think the word you're looking for here is efficiency, right? Things look to, like things will stay at the most efficient, like in the long run, things will seek to be in the most efficient way they could be. If water, for example, water, right? If water, like is somewhere where like it's like the water cycle works well, you're always going to be always going to have water there. While like in places where like there's not as much water, it will like become vapor and suddenly there will be no water there. For example, like things stay where they work. Like stones, like rocks won't move unless like someone moves them, for example, like you said. Yeah, like yeah, I think it maybe equilibrium, maybe efficiency, I don't know. Like I think those
Well, things will sort themselves out. I mean, look at a density tower, right, where you put all the different density liquids into a big, you know, container, right, and they sort themselves out via relative density. So, I mean, things will sort themselves out vertically via relative density, and things of the same density will sort themselves out horizontally.
PJ, can
Fair
I just
enough,
ask
fair
you? Do you know in a density tower? Do you know why the heaviest thing goes to
Yeah.
the bottom? You know that's due to gravity.
Wait, hold on.
No, that I mean, that would be the claim. No, I get you, right? So yeah, that would be the claim.
That is the force pulling the heaviest thing
No,
to the bottom.
Montrex. Don't try to like speed things up because I think we're getting somewhere. Hold on.
I was just like it was a simple. I mean, it's a simple point that there has to be something pushing that down or not, or pulling down in this case.
Yeah, but he says that we don't know the cause. So I'm trying to see
Which
like how much
gravity?
we know.
Which gravity do you think's pulling it down?
So
Yeah,
gravity.
that's the
gravity.
problem.
Gravity.
Yeah, which one?
What is gravity? What do you
That's
want?
what we're trying to figure out. That's what we're trying to figure out.
Yeah, you got to pick. You got to pick one. You got two to pick from.
It's the displacement of space time.
Yeah,
Hold
but
on.
that look, that's theoretical.
It's not.
You know,
theoretical,
that's just
it's
only going to exist on paper,
theory.
right? But you
Hold on.
can't validate that.
You
Hold
can.
on, let's continue because we can get there. Hold on, we can.
Okay.
Well, you just called it a well. 1 second, Necros. 1 second, right? You just called it a force, right? So that's not even claimed to be a force in your model of,
No,
of
I didn't
gravity.
say it was a force.
You literally just said.
I
that.
said it pulls down. Something has to pull down. It's not.
No, you said you literally said force. That was why
Well,
I
it's a
mentioned that.
gravitational force.
You did say force.
Gravitational force.
Yeah. Anyway, look, that's the claim. I understand the claims from the globe side, right? I've been over this hundreds and hundreds of times, right? So, what it's going to come down to is, you know, I'm going to say, right? These things never would have fallen unless a force, you know, some energy was exchanged, right? Forced them out of equilibrium, right? And that's the only reason that they dropped, right? And they're just resorting themselves out due to relative density. Right, you're going to say it's mass attracting mass or bending and warping of space-time, right? And then I'm going to be able to demonstrate my claim, right? And then you're not going to be able to demonstrate your claim of the cause of the effect. That's what it's going to come down to. But I'm happy to just say we both can't validate why up is up and why down is down.
Fair enough. Let me ask you.
Wait. Come on, sec. We can make predictions in our solar system. We can predict with 99.999%
Don't deny
accuracy
that,
where Mercury will be in 379 days based on gravity.
No, these are
That has nothing
post-dictions.
to do with gravity, dude. That's just like
Yeah, this is
So-
cycles.
So your
solar
argument,
cycle. You can predict. Everybody's like, oh, it's gravity. You can predict. Solar
Mr.
eclipse.
Coffee,
No,
Mr. Coffee, if
it's
you could just listen for a second. We can predict where a
Sure.
solar eclipse will be to the square mile. So yes.
Yeah,
we
but
can.
that's done via using the Saros
solar
cycle, right?
cycle, Saros
Yeah,
cycle.
so the Saros cycle, it's a post-diction, right? Because all of these things are cyclical,
Not this
right?
was
So the
gravity.
Saros cycle was created by flat earthers, right? A long time ago. And that's what's still used by NASA. So it's not predictions, it's post-dictions.
Okay, but if you listen, right? Anyway, oh wait, sorry, I forgot what I was talking about. Anyway, on Necro's point.
Mhm.
Wait 1 second. Wait, give me 1 second. I quickly have to unlock the door. Someone's at my house. I will be
Okay.
back.
Okay. So yeah, we can test over and over again that there's two primary vectors, up and down. Why do they exist? No one knows. Right? Why do things rise or sink though? Right? That's relative density, and we can prove that. That's easy. Like we can set up a scientific experiment and easily prove why things, rise or sink. But yeah,
You won't
what
do
it
that.
ends up
You
coming
won't do that with gravity. Can't set up a little experiment for that.
exactly. So that's why I'm happy to be at somewhat of a stalemate on that one, because we can't. No one knows why down and why is down and why is up. But
You
there
like my
are,
little meme? My
what's
little meme about George Soros's little bike. Come on, it's kind of funny, right?
the Soros cycle. Oh my god!
Hey,
Sorry.
Did you just make that now?
Post. I'm back.
No, it's better have for a little while.
hey,
I'll use
but
it.
Paraplegic Coffee, you guys, can you make, with what shown working out, any prediction using a flat Earth model? Any prediction of where the stars are going to be, when there'll be an eclipse?
It's all cyclical, right? It's all post-dictions. It's not predictions. It's not like the stars don't do don't move in cycles, right? So even the flat Earth ancient cultures, right? They all were obsessed with the stars, right? They had all of that charted out, and it just moves in cycles. It comes down to a bunch of assumptions. When you want to incorporate it into the globe model, right? There's a whole bunch of assumptions that would need to be validated.
What are you saying by it moves in cycles? I'm a bit confused by that.
It's just the patterns. It's the same thing. The same things happen for the past 50 years in the same way. It keeps happening. So it's like, why wouldn't it happen
Well,
again?
exactly.
It's the same way like you
say
see.
that, but the North
You see
Star
the
was a
mailman.
star
You see
for
the
thousands
mailman
years
every
ago.
day at 10 o'clock. So, wow. Well, hey, man, I guess you can make up a scientific whatever. Dude, sometimes correlation isn't causation, and you say it's gravity. So, which one is it? Is it mass
gravity.
attracts mass? Is it mass attracts mass, or is it the bending and warping of space time? Is that what causes
It's both.
in your little? It's both. Okay.
Yeah.
Well, no, it's not. It can't be both.
It can be both.
Apparently, it is.
well,
No.
hold on, because
Yeah.
I think he misunderstands the claim. It's not that it's both. It's that the mass attracting mass is the bending of space and time.
Exactly. Yeah. So it is both.
According to the explanation.
What?
Not according to physicists, no.
But I didn't even want to get there. Because I wanted to
Dude, completely. One is different than the other. You're bending and warping freaking conceptual ideas. Mass attracting mass is just like, stuff attracts to stuff. When have you ever seen stuff attract to stuff? Ever?
Here's the thing. The claim that's being made is that
Wait,
mass
Necros, can I
attracts
quickly
mass
just answer something? Can I quickly just answer something he said really quick? When have I ever seen mass attracting mass? Well, okay, I have my headphones right here. I'm going to let go of them.
What?
Oh,
Mhm.
there we go.
Yeah, they're more dense than the surrounding medium.
Yeah.
Okay.
Yeah, you lifted them
You
up,
let them go,
and they're more dense. They're more dense than air, so they're going to sink once you release them.
So how does it know which way to fall?
There's two primary directions, up and down, right? So if you want to claim, I'm not claiming to know why down is down and why up is up, but I can validate why something rises or why something sinks, right? The cause.
If it's heavier than the air, if the headphones are heavier than the medium that they're in, the air, they're obviously gonna fall.
Yeah. So if you want to claim that a cause and effect relationship, right? If you want to claim that the cause is the bending and warping of space-time, right, then you would have to present a scientific experiment that manipulates the cause of the effect, right, to prove that that is the cause of the effect. Now, when you ask people like Neil deGrasse Tyson and other scientists, what is gravity? They say we have absolutely no idea, right? We don't know what it is. We don't know where it comes from.
They do not say that. I can.
Do you want to hear him say that? I'll pop it in the side chat.
Next question. Here it comes.
Do not say
20,000 people.
Okay, well we're gonna look, dude. I'm not gonna say something if I can't back it up. That would, that would leave me open to. So I'm gonna pop it in the side chat.
Okay, I'll have a look.
If he says, look, Neil deGrasse Tyson says that stuff is flat. He
said
we don't just make shit up. We're not here just making shit up.
He says it's flat from a particular height. That's what he's saying. He doesn't think the Earth is flat.
Yeah. But still, he said it's flat from frickin' Neil Baumgartner's space jump, where everybody says you saw the frickin' curvature. You clearly saw the curvature when the guy jumped from space, and that's all bullshit. So. Can't see it from that.
Yeah, so there's a clip in the side chat.
Neil deGrasse, steal the bike. Said
these guys have said it a ton of times as well. We've had physicists in here; they'll say the same thing, right? They'll say we can measure the effect, but we can't prove it, right? It's not something that can be proven through the scientific method.
Oh yeah, because humans can't create planets, is why we can't test it. Like,
hold on, Jesus Christ.
Like
let's go back to the conversation because we
can test it with a simple. I can't remember what the experiment's called, but there is a way to measure. But anyway, I'll let you know.
Montrack.
Cavendish is coming.
Also, no, it wasn't Cavendish. Also, this clip, I've seen this before. It's also taken a bit out of context. But anyway,
how is it? Which part of it's out of context?
The Neil deGrasse Tyson thing.
Which part of it's out of context? Which part?
What do you mean? It's a 3-second clip.
He asked them what's gravity. Neil says, we don't know. Next question. Or I don't know. One of the two. Basically, they mean the same freaking thing, but I don't know. Next question.
Watch the whole interview. You'll see how it's taken out of context.
I've watched the whole interview. It's very clear, and I've heard many scientists say it. Right? They don't know, right? Otherwise, okay, go ahead and present the scientific experiment that proves it. I could ask you, what is gravity and where does it come from? Right? They don't know.
With actual degrees,
you keep talking straight over the top of me, bro.
I'm sorry. You're absolutely right.
So.
I'll let Necro speak for a second.
Yeah, please.
Sorry.
So, DJ,
I appreciate you chiming in, paraplegic, but
you're right.
we gotta take turns. That's all.
DJ, I would like to go back to like because we were getting somewhere, but like he started like making the claim, which is not what I wanted to do at all.
Gets that way.
So
okay, go ahead.
We know the force, right? We know. No, not force, but we know there's something there, right? That attracts. There's a reason why it falls.
No.
We know there's a phenomenon.
Yeah, I would say that's the force that displaced the object. Right, some energy exchange needs to happen from an outside source for something to rise or sink in nature. Right, nothing just rises or sinks just by itself. Right, whether it be energy from the sun or energy from like the wind or a person or something, something needs to displace something and take it out of equilibrium, and the object's just going to re-seek equilibrium.
Sure.
And look, obviously that can't be the case on a globe. you need to have that like something, you know, to explain water sticking to the outside of a globe and that sort of thing. You can't have the globe without gravity. I understand that. So you guys would need to defend gravity to the death, or you can't have a globe or the entire globe model.
Yeah, you're 100% correct. Without gravity, there's no globe. You're 100%.
And it would be slightly different in the context that I'm using my relative density claim, where we have a stationary Earth inside an enclosed system. And it doesn't move, right? So we don't need to explain water sticking to the outside of a ball and that kind of thing. So we don't need your version of gravity.
Hold on. You are 100% correct in the sense that without the concept of gravity, the globe would be impossible. You are 100% correct. But that's why I want to understand how the force in your version of the world, or force or phenomena or whatever, how that works. Because, for example, there are a few characteristics that we can attribute to it, and that's what I'm trying to get to and see if you agree with me or not. One of them is that, like, we know things fall down. You say, like, oh, if you, like, bring something up, it will fall down. Fair enough. We know it affects pretty much everything, even though it affects it differently, but it does affect that, like, pretty much everything, from gases to because we know that some gases that are very dense, they will not float into the not float into the sky, for example. Like, heavy gases will stay in like lower places. That's why, like, colder air.
Can I touch on that just for a second?
Yeah.
So the gas particles, right? If you get a gas like SF6.
Mm-hmm.
You know, it's not a natural gas, but it's a very dense gas. It's like 5 times more dense than oxygen or something like that. Anyway, like, the gas particles still move at random in all directions. Okay, so if you have a fish tank of SF6, right, you can float like a little aluminium foil boat on it, but literally, like, a few hours later, all of that gas is going to blend with the air, right? Because the gas particles are still moving at random in all directions, because it's the kinetic energy, right, that's going to cause diffusion, right? And it's going to blend in, and none of that SF6 is going to be left in the bottom of that tank.
Fair enough, but will it, you know, like, float up into, like, for the ceiling of the ceiling of the room, for example, or something like that?
Well, it will blend in. It will blend into the air. It won't be.
Oh,
it won't be sitting at the bottom.
It will split, like, it will. Okay, that makes sense. But what we got here is that I'm not trying to prove that you can, you know, keep gases in an open container. That's not what I'm trying to say here. What I'm trying to say here is that we see that force or that phenomena affects gases as well. Like, and we can talk about the medium, for example, like O2. This gas is heavier, therefore it's like under, like, this gas is like you know, more massive or whatever, has more density. That's why it's down there. Okay, we can claim that, but we also know that it is affected by this same density principle, at least. You know, we know.
Well, the thing is, gases are very different, right? A gas particle will move indefinitely to fill any available space, no matter what the size is. It's moving due to kinetic energy at like 500 meters per second or something like that. Now, they don't have a directional bias. Gas particles move at random in all directions, and I've never seen any experiment that shows gas particles having a downward bias, right? So if there's a gas particle going up at like 45 degrees or something like that, you know, it's going along. It's only going to change direction. It's only going to change direction between collisions against other particles, or if it bounces off the wall of its container. Otherwise, it's just going to indefinitely move in a straight line. So that's the interesting, crazy thing about gas particles. It's in the definition of gas particle movement.
That's why I would like to see a multiple container vacuum experiment, because if we have, like, for example, gas trapped within like the gas trapped in a container that is smaller than another container that is a vacuum, for example, and we release that gas, we release that air, in theory, it's not going to be enough to fill the entire container, and it should then stay at one point. I would totally like to see something like that, to see how gas would be.
Yeah, it doesn't. It will just equalize. I mean, it will no longer be a vacuum in there anymore.
Yeah, so,
Right, it'll be pressurized.
So I understand what you're saying.
But it will like gas fills space, available space, right? That's just like what gases do. So I mean, if you have any container, like to be able to demonstrate any gas pressure higher than 14.7 psi, right? You need a container.
DJ, I know what you're saying, but try to follow me here. If we, and I know you're capable of doing that because you're a very smart guy. If we do that, right? If we do that to like multiple containers, and we, like one of them, the outside one is a vacuum, as in there's no gas there. We open the container that is that has the gas, that houses the gas within this container. The gas should eventually settle in a position, or else we just discovered perpetual motion.
No, the high pressure will instantly equalize with the low pressure system. I can show you an example.
I would like to see that, but the thing is, if the gas can't fill the entire environment, there will always be a part of it that will have no gas. Let's see. Yeah, let me watch it because I've seen this before. I think you've shown it to me before. Yeah, it equalized.
Instantly.
Yeah, it equalized.
Will instantly and violently fill any available space.
True.
Right? Just like if you pop a car tire. I mean, it's
true, but
it's just what gas does, I mean.
But what happens if the space is big enough? You know, like it's large enough for the gas to not be enough? Because we know like there is a length. Like gas can't multiply itself, right? There will be a space that will be too big for even for the gas to stretch itself out to be, to fill the entire thing.
Well, the gas particles will still just move at random in all directions, and they will bounce off each other and off the walls of their container. Like the gas particles don't, like, if a gas particle's going up, it doesn't have like a parabolic arc and come back down to the ground. If that were the case, all the gas would be stuck to the ground, right, where the gravity would claim to be the strongest. Mm-hmm. But that's not what happens with gases, right? The gases just move at random in all directions.
But if you do that, wouldn't that, if like that scenario happens, wouldn't that just be perpetual motion then? Because it will.
Well, instead of being a vacuum, it would just be a very, very low pressure system. And the gas particles would be shooting around in all directions, and it would be. Yeah, it would be just a higher torr than.
So that would be perpetual
when
motion,
it was a vacuum.
There. That would be perpetual motion, right?
Well, that's the kinetic energy. It's only because of the heat gives the gas particles kinetic energy, and that's the reason that they move. And that kinetic energy far exceeds the weak force of gravity anyway, according to the globe side.
Yeah, but that would create a perfect system where it doesn't spend enough energy to stop moving, and it has enough energy to continue moving. It might not generate energy, like more energy, but it definitely keeps moving forever if we take that into consideration.
Yeah, they don't even lose kinetic energy. Like even when they bounce off each other or bounce off the wall of the container, they don't actually ever lose any of that.
Perfect elastic collisions.
Yeah, it's crazy.
Yeah, so that creates a perfect
interesting.
system. So we just discovered, if that's true, we discovered perpetual motion.
No, this has been discovered. It's called perfect elastic collisions. It's used in chemistry.
Yeah, I mean, exactly. And all you can do, like you can manipulate the heat, and you can have the heat slow down. Speed up or slow down. Like use temperature to speed them up or slow them down. But you're not going to be able to get them to, have parabolic arcs and
because it will never stop, right?
That sort of. You'd have to get it to yeah, definitely not.
Because in theory, the gas should never stop because it's not. There's always going to be space to be filled, so it should be like being sucked by that space instead of like normalizing and stopping, like settling in one place. And if it doesn't settle in one place and it keeps moving, that is by definition, and it's not spending energy and enough energy to stop. That is by definition perpetual motion. It will be moving forever.
Yeah, I don't. The gas part. I've never heard of a gas particle stopping. You would have to get it down to like what to like 0 or whatever.
Yeah,
It's impossible.
I would totally like to see that experiment happen now, because if it happens, one of two impossible things will happen. The gas will settle, and the vacuum, like, we will have an area with vacuum and an area without vacuum, or we'll discover perpetual motion. So two of those things are thought to be impossible, right? That's
Well, I mean,
totally...
look, yeah, look, I'm not sure what you mean. I mean, like, if you, like, the gas particles just move randomly in all directions, like fill up a balloon, and
yeah,
you know, it's
indeed.
not like the gas particles are going to settle at the bottom of the balloon eventually. That's not what happens.
Yeah, but the gas does escape the balloon eventually. You know, if it's a space that it cannot escape.
Well, it's only going to slowly leak out because it's porous. The balloon, is porous.
Yeah, we would need something that is not porous and the gas would not be able to escape from to do like such an experiment, for example. Because yeah, you're right. The gas will not, you know, it will not stop moving in the balloon, but it will eventually escape the balloon. So we wouldn't have like.
There's other things that I think I don't know if you've looked into superfluids before, but I think if you move, like, put some superfluid in motion, I'm pretty sure that never stops moving once you set it in motion. It's crazy stuff, right? Have you seen videos about that? Right, you can fill up like a beaker or a glass with liquid helium superfluid, right, and it will leak through the bottom of a glass. It has zero viscosity. It's crazy stuff.
I will
climb up walls and yeah, I'll post a video in the side chat. It's really trippy.
But going back to the other argument though, because this experiment, I would totally like to see that happen. Like multiple, like someone setting like I don't know, like multiple layers of you know, like a vacuum, like creating a vacuum inside of, I don't know, like a medium, and then like keeping one with the gas there, and like, you know, releasing the gas within the vacuum and seeing what happens if the space is way too big for the gas to spread. That would be like an interesting experiment to see what happens.
Yeah, a gas particle's just going to keep moving around, right? It's just going to go in a straight line. Just say you had one gas particle in there, right? It's just going to move in a straight line, and it's going to bounce off the container.
Mm-hmm.
And now and then. Otherwise, if it's a giant container, it's just going to continually keep going in a straight line until it does reach the wall of the container.
That'd be a very interesting thing.
That's what the definitions say. I can try to find a quote from
so if I ever
someone
find
that's
that, so if I ever find that experiment or ever see that happening, I would totally like to revisit that with you.
Yeah, cool.
But if you don't mind, I would like to move on a little bit after your post.
Yeah, that's fine. Look, if you see Jedi knows like 1,000 times more than me about this stuff. So if you talk to Jedi about it sometime, he knows like way more than I do. It's definitely not my topic that I'm well versed in.
Totally. I would just like to ask a little more, like inquire a little more about the force, if you don't mind, or the force or the phenomenon. Mm-hmm. Actually, let's not say force, because again, that would be making a claim. We know, right? That things fall down. We know density is a big factor of that. Do you think pressure plays into that? Because we know, like, when you're in between two very big mountains, right, your ears pop. Why is that? Do you have an explanation for that doesn't involve the same force being applied in a different direction?
I don't think that has any effect on how quickly things fall, does it?
No, it does not. It does not. It definitely doesn't. But I would like to ask you. Yeah, you're right. That is a valid thing, right? That's a valid. Where would they even find a container big enough for a gas not to fill? Well, it's just they it's not that the container has to be like super big. It just has to be like a small container with gas, and like the container with gas has to be much smaller than the bigger one. So like we can scale that up and down.
Yeah, so as soon as you take the lid, or as soon as you make a hole in the container that has the higher pressure, it's just going to equalize with whatever pressure is on the outside. So just say you have a vacuum chamber that's like 10 to the negative 3 torr, right? And then you have another little chamber inside it that's like 0 torr. And you, as soon as you like separate the boundary, right? As soon as you like open the two systems together, the 0 torr is just going to fill the available space, right? The gas particles in there are just going to equalize, right? Diffusion's going to take place, and it's just going to equalize, and then the entire container will be, whatever.
Yeah.
Pressure.
Yeah, the thing is,
there's not going to be any higher pressure left inside that 0 torr container. It's just going to be equal with the outside.
You are correct, but the thing is, that container should be able to be filled if the gas is like, if there's enough gas. But if there's not enough gas, how will the gas fill that? You know what I'm saying? Like, gas can't multiply forever. If you put, like, for example, like a small container, for example, like a small bottle of O2 in a building that is completely, like closed off in a vacuum, in theory. This is a theory. This is a hypothesis, right? Like closed off, and like a little bottle, like a little like plastic bottle, like Coke bottle of air. You open that air, the air will try to fill out the building, but there will not be enough air to fill out the entire building, for example. So what would happen to that?
It'll still be over time, right? It will just be equal pressure everywhere in the building, roughly. And and then obviously it's not going to be a perfect static system, because you're going to have temperature differences and things like that, which are going to create different density layers. You're going to have like a gradient because of the temperatures. But if you had a perfect static system where the temperatures were, everything was accounted for, then yeah, you would have the same pressure everywhere in the system.
Mark, you say there can't be not enough gas, but how would the gas spread that much? How would
each particle will just go off in random direction and just keep moving until it hits a wall of the container or bounces off another particle. So even if you've got 1 million particles or 1 trillion particles, they're all going to do the same thing. There's just going to be more collisions if there's more particles. That's all.
Fair enough. I got to look into that. That's interesting.
Yeah. Here's the quote that I was looking for in the side chat. Have a look at that one. It's James Clerk Maxwell.
I see. I'm looking into the gas thing right now. That's why I'm kind of quiet.
Mm-hmm. Yeah.
Because there is a reduction in pressure. Because what I'm seeing here is, and granted, I didn't look it up like very deep. This is an AI answer, so you can just fact check this shit if you want to. But like, it says yes. In general, a gas will expand to fill a vacuum. To extent to which, to the extent to which this happens depends on the amount of gas present and the size of the vacuum. If there is less gas than the volume of the vacuum, the gas will distribute itself throughout the available space, but the pressure will be lower than if the space were completely filled. So this implies that the space is not completely filled.
Yeah, that's what's going to happen, right? So all vacuum, there's no such thing as a perfect vacuum. So you're always going to have some gas particles. Okay, so if you just have different levels of vacuum. So as you add more gas particles, it's just going to be less of a vacuum, all the way down to however much gas you want to stack into that container. And then it's not going to be a vacuum. At some point, it's just not going to be considered a vacuum. But I mean, technically, anything under 760 torr, which is 14.7 psi, that's like a low vacuum. And then you've got like medium vacuum, and then strong vacuum, extra strong, and whatnot. So yeah, the more gas, the less gas, the more vacuum. The lower pressure it's going to read inside that system. But regardless of how much is in there, all the gas particles are going to behave the same. You can only manipulate what they do by altering the temperature, and you can speed them down or slow them up. That's all.
Interesting. I would totally have to look into that. I will totally look into that to see, and I would like to revisit that conversation when I have more knowledge on that. But going back to the question I asked you earlier about the pressure, right? Pressure in between, for example, two large bodies of like rocks, for example, like mountains, and how your ears pop when you pass by them. Do we have an explanation for that? Because we know there's a difference in pressure there, or at least I assume we do. Just like how when we're flying, there's a difference in pressure there as well. Do we know why that happens?
I think it's just due to the temperature, isn't it?
It might actually be.
I think it's.
Well, you look at the ideal gas law, and those are the variables that you need to look at to change to cause a change in the gas pressure. You got PV equals nRT. So the variables that you're changing are going to be the volume of the container. The T is going to be the temperature. So, yeah, those are the probably only two things there that could be causing a change in the pressure.
And that applies for the mountains as well?
Well, you're talking about the higher altitude that you go versus staying at the same altitude and just having two mountains on your sides.
Yeah.
The pressure should be equalizing unless there's a pressure difference. But I've never heard of anyone's ears popping between two mountains. You have to rise in elevation to get that effect.
Yeah, that's right.
And that rise in elevation is when you're going to see the pressure change. So yes, there is a less pressure the higher up you go, but there's still a pressure. So there's still a V and a T. And all the gas comes from the ground and goes up as the first thing. So definitely not being held down by gravity.
And do we have an explanation as to why the pressure becomes more the lower we go?
That's where it's all created. What gas?
Yeah, because it's a dynamic system. Like all of the gas that makes up the air is created at ground level.
Yeah, but like underground, for example, why does it become because like at ground level, yes, but like as we go under, like for example, like down, like as we go, as we dig down, like the pressure becomes more. Why is that?
It does.
Like the citation for that.
Well, it does measurably. At least like I will make that claim for water, but that's a different situation. I'm pretty sure it happens in land as well. Let me just fact check myself.
That may be the case. Like pressure increasing depending on altitude, no problem. Why that is, we don't have any kind of cause to give you.
Okay, yeah. So I was right. So yes, like pressure generally increases in caves as you go deeper, just like on the surface. So what appears to happen, and I would like you to look into that, and I'll take my word for it. But what appears to happen is that as far deep as you go into like Earth, the more pressure there is.
Okay. That's fine. What about it?
I'm asking you if we know why.
I just told you that there is no cause to give for that. That's just an observation. The cause would be an entirely different thing, right?
Totally.
Right.
Totally. But we observe this exists.
Well, it's simple as
Yes.
there's more air. There's more air above
Right.
you, so you're under more pressure. It's the same as water. There's more water above you, so there's more pressure on you.
Yeah, I understand that explanation. I'm trying to get an explanation out of them, but I can understand that one.
Why would you want us to explain something to you that we couldn't give you a mechanism for the cause?
No, fair enough.
Why would you-
You don't need to.
Right.
You don't need to. You don't need to.
Right.
I'm just asking you that because if we observe something, there must be a cause for that something, right?
Right. So there might be, but sometimes those causes cannot be found. That's why even to this day and age, the cause for what you're observing and what we're observing at the same time, there is no testable explanation for any of that. Nobody has even made one.
You are okay. I understand what you're saying. You said there might be. So let me ask you a question. Can there be something that happens without a cause?
I mean, things happen. Yeah, like there's always going to be a cause, right? I agree with you, but sometimes those causes can't be found. I don't know why you're harping on this position. Do you have any cause you could offer us that we could test?
I'm asking you. No, I'm not trying to make a claim here. I'm just asking you. I'm not gonna hold that against you. I'm just asking. Just making an observation. Because yes, there is an explanation to that is not testable. So it's not acceptable within your parameters, for example. So I'm not going to.
Then it wouldn't be an explanation then, because typically explanations are, a summation given after a test has given you the cause found. So what you're telling me is actually just someone made up a story. Like I could tell you, if you tell me that gravity is the reason for that, and I tell you that unicorn farts are the reason for that, both of us have the same level of plausibility.
Not exactly, because the claim behind gravity takes into consideration a lot of phenomena that can be observed. We just can't really go and reproduce gravity by creating a body that attracts other bodies within Earth, which would not be technically acceptable within the standards. I mean, I have had discussions of the vacuum before, right? And how it is impossible to prove that a vacuum, the gas will not spread around the vacuum, because simply we can't do that without a container here. So the test would be pointless. You understand that?
What's gravity? You're saying gravity, the idea of gravity explains things. We have lots of phenomena. I'm going to go ahead and blanket state and say all the reasons for the phenomena that you observe as unicorn farts. Prove me wrong.
The thing is, you are
Can't do a calculation and a prediction based on unicorn farts, can you?
No worries. It's 9.8 meters per second, right? Unicorn farts make things go down at 9.8 meters per second. There you go.
The phenomena people name gravity. It is
There's no phenomena for gravity.
It is a fusion of a bunch of observable things that we have observed, and then
No, it's not. That's a lie. That's a lie.
Wait, hold on. So when things fall down at a certain speed, is that not something we observe?
In water, things don't always fall down in water. Is that what you're talking about? A lot of things go up in water.
No, we're talking about things in air, for example, or water. Yes.
So this is just in air. So you are picking and choosing, and you have phenomena in air that differ from a different medium. So now all of a sudden you're just going to go ahead and selectively say, in air, we only observe gravity, but if I change the medium, all of a sudden that stuff doesn't happen, right?
No, the medium definitely matters. I'll give you that.
Oh, okay. So then when stuff goes up, now what?
In a vacuum, right? They will follow the same speed most of the time. So
another medium change. So now we've totally changed the medium again, and so you selectively choose the phenomena based on the medium. That sounds like cherry picking to me, or something like that.
That's who. I just agreed with you. Why are you fighting me? I just agreed with you. I said, yeah, the medium.
I'm right. Right. So then we don't actually have any phenomena to observe because different mediums produce different phenomena.
Could you stop assuming things? Because medium definitely matters. Yes, the medium definitely matters.
Right.
So acceleration will be different in water. It will be different based on density. You're 100% correct. I will not disagree with you on that.
Uh-huh.
It will also
Right.
it will also matter as to how deep something will go into water. For example, like just because something is heavy at the top, it doesn't mean it will go all the way to the bottom of the ocean. For example, right? All those things matter. All those things matter.
And so all those things matter, and that's going to help you with gravity. How?
So we have to observe different medium and how they interact with different medium. You're 100% correct. The thing is, within those mediums, they tend to be, they tend to be consistent in their measurements. That's the thing. That the consistency is what matters, because you're 100% correct. Medium matters. And if I chose like only air, that would be totally cherry picking. Because again, like if I drop iron in like if I'm like at the top of a building and I drop iron to the floor, it will fall at a speed. If I put the same iron bar in a river, it will fall at a different speed. Different mediums, different speeds. You are 100% correct. The thing that matters if we drop 2 bars of iron in water, they are the same weight. They should be consistent as how they at the speed they fall. Just how we should do the same thing in air, and they should also be consistent. The thing is, that medium totally matters, but we know that there is a consistency within those mediums at the speed.
What is your point?
The thing is that we can then calculate that speed, and we can know and we know there's something under. There's something that the reason why we know there's a reason why they're going down. Based on
what would that be? What would that be?
That's what I'm trying to figure out with you, right? That's what I'm trying to spitball with you here. So that is an observation that we can make, is it not? That's
because what would that be? Give me a cause. Do you have a cause to propose at this point?
Hold on, we're getting there. Be a little patient.
You're wasting my time. We can just get to the end real quick. What is the cause for that?
We cannot, because there's more than one simple thing to the observation. But is that something?
Not really.
Yes or no? Is that something? Because that was the first thing.
I just agree with you. What is the cause for the observation that you're making? This is not going to take long.
Okay, I'm not making a cause here. I'm just trying to show you how people get to the conclusion that many things come together to form what some people would call gravity, right? So, for example,
what is that?
What is gravity?
Yeah.
What is gravity? I would explain it to you. I would have to give you the explanation, the scientific explanation, because if I tell you like it's the force that attracts things to the floor, to the ground, I would be making a claim that there is a force there.
Okay, so you have a force. So how can we test this in an experiment? Can we go to the gravity tree and pull some gravity off and use it as an independent variable in the experiment?
Every single time we mention like making predictions or anything, you just go and we use gravity as an example. And then your only answer is just to go, no. No, it wasn't, I was asking you for a specific experimental example of this force at work. Of gravity?
Well, one of the things we know is that there is a set speed as to how things fall. So therefore there's a certain acceleration that happens, right? Which tends to be consistent and around a certain value. That can be calculated and we can say, for example, that's gravity, for example.
Bro, you're wasting my time. So you're telling me that the observation is the gravity?
No, I'm giving you an example as to, like, for example, something that we can claim to be gravity, right? We can claim that.
Who cares about the claim if you can't prove it?
Well, if there is a consistent acceleration, right, that falls. You agreed with that.
There isn't. If we change the medium, but then all of a sudden now we also have things going up, which also debunks the claim. There's not a consistency of anything going down.
Well, it actually does not. It actually does not. You see, because medium matters. You forgot. And if something is less dense than air, suddenly it goes up. Just like in water, if something is less dense than water, it certainly stays at the afloat. How does that go against anything?
Well, I'm just showing you that not everything goes down. Some things go up too. Lots of things go up. In the medium. So we don't have a consistency of downward acceleration. We also have things going up at different different speeds. So what are we supposed to do with all this?
You are 100% correct. Things do go up, and it's depending on how the force how they are affected by this acceleration, right?
Accelerations aren't forces. Accelerations are measured speeds or measured rates of motion.
You are correct. That's why I corrected myself and didn't say force. I corrected myself after that.
So we have more observation. We need cause. What we're looking for is cause, not to affirm the consequent and say, if something goes downward, therefore gravity, we would have to go ahead and say, what is the cause of things going downward or upward? That would be the thing we're looking for.
But you are forcing me into giving you a cause when I'm trying to simply illustrate a few things that make up the explanation as to why people claim...
It's not an explanation unless there's a tested experiment. There's a tested cause.
We can totally observe and test the acceleration in different mediums. We can totally do that.
Okay, so we can see things happening. Great. Now what's the cause for the thing happening?
Exactly, that's where I'm trying to get, right, too.
We've been here for 10 minutes. You've been waffling and just jacking me around. Just give me the cause, or do you not have one?
It's because every time I try to speak, you try to speak. You start speaking over me. Is that?
No, it's not that. I'm asking you a very pointed question. Either you're going to call the actual observation the cause, or you're going to give me a cause. Which one is it?
The observation is not the cause.
Okay, great. So what's the cause?
We can also observe that as we go deeper, pressure becomes more. As we go up...
All right, so more observations. Yes, more observations, yes.
You know how we get to a conclusion? When you observe a bunch of things and then you draw the conclusion, right?
No, you don't. You just don't observe and declare. That's not science. That's not even logical.
So you're telling me that you can't observe phenomena and get to a hypothesis based on that? For example,
the hypothesis is the thing that you test. So I want you to give me the thing that we would be testing to get the cause. You can't just observe, think about something, and then declare. Because, like, again, I could say that all these observations, unicorn farts, that's my logical explanation for everything that happens. And it's just as viable as yours.
Yes, it would be when new unicorns existed.
Well, like, if gravity existed, that would be the cause, but we know gravity doesn't exist. You know that gravity doesn't exist. I know that unicorn farts aren't real. You know that unicorn farts aren't real. So we're in the same footing.
You know that very argument is the reason why religions still exist, right? But let's
terrific. Now you're going to bounce to religion, but we're going to talk about today as your presumed cause in an experiment that you're going to test for all these observations. And what would that be, by the way?
I'm sorry, have I made any claims since I started?
Okay, so you don't claim anything. Great. You don't have a cause for the way that these things do what they do. I'm glad we both agree. We can't test any cause because we don't actually know what to test for, do we?
Yes, but that's why we observe things, to try to figure out what we test.
Great. We're going to continue to observe. Yeah, we're just going to observe and then make shit up. That's how you want to do this quote-unquote science of yours, right?
Are you against observation? I'm sorry, because we have some...
No, I didn't say I was against observation. I'm against people observing things and then declaring a cause for them when they haven't tested anything. I'm against that.
What have I declared exactly? I haven't declared gravity.
Okay, then you're not declaring any cause or any force. We're just seeing things go up and down, side to side. That's all we're observing. Great.
Hold on, give me a second.
Do you think you and I could get to a cause, or do you think we should just continue to observe and declare?
Wait, give me 1 second. I would like to ask DJ a question while he's here. DJ, are you still here?
Yeah.
DJ, at any point have I made a claim? I'm just trying to understand the views of people here on things. He's trying to force me into getting to the gravity debate. If you think I have, I will apologize to everybody here. But have I made any claims, or am I just trying to understand if you guys have
Or
explanations?
didn't I just tell you that both of us agree that there's nothing that we can claim as a cause? I think I just told you we both agree. Great, nothing we can test. So we don't have to make claims about what the cause might be. And now you're going to cry to DJ and say, this guy's making me come up with a cause. You can absolutely not claim any cause and we're good.
Setsu, do you understand that I'm not saying that observing something is a cause, but I'm trying to say that if you observe enough, you might know what to test for.
Great, what are you going to test?
Exactly, that's what I'm trying to figure out.
Right, well, what is it? What do you think you should test at this point? I've been asking you this since the beginning.
There's a bunch of observations we can make based on the fact that...
Oh my gosh, you are on repeat. I'm going to mute your dumbass for a second. You're going to listen to me. You are on repeat, my friend. You can make all the observations that you want. If you think that there's something that we can test to go ahead and solidify a cause for the dependent variable, that would be the thing that you observe in nature, then please give us some kind of independent variable that we can test. If you can't think of something that we could test, then we're all done here, because neither can I. I don't know what I would be able to test to have a cause for these observations of things going up and down. And I don't really, I mean, it's kind of pathetic that you would cry to another mod and say, he's trying to make me do this. No, my friend, just go ahead and make the observations. But if you don't have any idea as to what it is that we're going to test to see if there's a cause for these things, then shut up.
You are 100% correct. I am not making a claim, and I'm not saying I have a thing to make. I don't have a claim that I'm making here or something for us to test for. I am simply proposing some questions here to see if we get somewhere.
You think all of us here in this Discord server on the internet, with probably not a big enough budget and probably not even enough knowledge about all of these particular topics, are going to come up with something, especially when nobody has, with the budgets and the intelligence and the data that they have, even to this day, no one has anything to test. So I don't think we're going to figure it out on Discord.
Are we not here simply for the pursuit of knowledge? Are we not here to understand the world in a better way, have deeper conversations? Because that has been, my intention when joining the server is to understand other perspectives and try to figure out explanations. Yes, we can search things, we can look into knowledge in certain ways. You are 100% correct. Maybe we don't. Maybe no one has figured stuff out like that. But asking the questions is like the point. Is the interesting part of it. I'm not saying that that I'm trying to claim something that my view of the world is better, because that wasn't my point here today. My point here today wasn't to say I know better. My claim here today wasn't to say we know certain things that you don't. I'm simply saying you asked me, do you have an explanation to that? And I'll give you, and I'll tell you something here. I do not. I am trying to.
Me either.
Yeah, that's cool.
But I'm not going to hold that against you.
Yeah, that's cool. I just want to let you know that when you say that things like the downwards acceleration or things falling is caused by gravity or is gravity, that is an inherent claim.
What I said is that could be, for example, something someone else would name, and then Setsu pointed out that I was naming the observation cause.
Bro, the theories of gravity did not pre-exist things falling.
Yeah,
everybody
I know.
Everybody knows things fall. Everybody knows things have weight. However, there are people who have theories and ideas of what causes that.
Yes, indeed. You are 100% correct. That is what I'm trying to talk about. So, as Setsu pointed out, claiming that the things fall, that the things fall is as gravity is naming the observation the cause, right? We know things fall down. Why do they fall down is the question, right? And the answer is, according to him, we don't know. According to the globe model is gravity. And that's not the claim I'm making today. I haven't made a single claim today. I'm just trying to understand if you have an explanation for that.
Well, I think we've given you the answer, right? So I think Monterex or Monturx, I'm not sure how to pronounce that, has been waiting patiently to ask some questions.
Go ahead.
Yeah. Well, how would you explain a lunar eclipse on a flat Earth? Is one of my questions. I don't mind who answers it, who wants to talk, but just wondered.
Yeah, so assumptions need to be made in the globe explanation, and what we've found is there are inconsistencies in the explanation during certain types of eclipses, such as the Selenilian eclipse, right, where we can see the sun and the moon both above the horizon during the eclipse, and the shadow on the moon is upside down, right? There isn't an explanation from the globe side for the upside down shadow. But, it's one of those things that does require some presuppositions. What's that, sorry?
I'd have to research into that specific phenomenon.
Yeah, absolutely. Yeah. Understandable. But yeah, there's plenty of video footage. It's Selenilian as well. Selenilian eclipse. If you want to have a look into it. Selenilion, I guess. But you probably won't find much there about the upside down shadow. But yeah, we can post some examples. I mean, you can look it up, but I don't think there is a mainstream explanation for that. It's called. They do call it like also the impossible eclipse, right? For these reasons, but they do say that because you can see the sun and the moon above the horizon during the eclipse, right? They'll say that that's like refraction, I think. Yeah. But the upside down shadow, no explanation.
Yeah.
But even just and also explanations aren't necessarily like the be all and end all. It's a little bit of a cop out as well. Just saying refraction.
Yeah.
Without being able to validate it.
But
that's the only explanation I could find.
Selenilian eclipses, just the total lunar eclipses. How would you explain that on a flat Earth? Because on a flat Earth model, surely the moon would have to be. I don't know how your model works. Lower than the sun, I assume.
Yeah, we don't make definitive claims about things that we can't validate. I mean, I would like to go over things like empirical evidence, like practical demonstrations, like observations and laser tests over massive bodies of water, things like that. When it comes to things we can't validate that require assumptions, we tried not to, speculate about those things, right? So we don't claim to know everything, right? Or have a replacement answer for everything the globe model claims, right? We're not even claiming to know the shape of the Earth, right? That's not what we're talking about when we say flat Earth.
Sorry, I'm just looking into this upside down shadow phenomenon.
Yeah. The only place you might be able to find some kind of explanation for it will be some kind of like anti-flat Earth debunking site, right? You're not going to find a mainstream explanation for that. But yeah, explanations most definitely need to be validated to be correct as well. There's some examples in the side chat of the upside down shadow as well.
It's important to point out that there is no flat Earth model. Anything that's been proffered by, let's say, other flat earthers is pure speculation based on zero data. It's kind of the same idea as like a globe Earth model, a diagram or a mathematical construct that is completely static or rigid. And is based on zero actual measurements of the Earth or, any curvature, because nobody's measured any curvature. So anything based on a globe Earth model, if you want to call it that, is pure speculation.
Well, and people have measured curvature very much.
Oh, really? When?
Okay, let's see that. Where, when, and how was that done?
When I mean, let me have a look now. I can find you.
Oh, you just said that they've done it for sure. Now you have to go look at something you already made a claim for.
I'm going to get you an exact example, but for sure they've done it.
Yeah, we're familiar with your ploy to like make claims about something and then not know what you're talking about, so you have to go look it up afterwards. That's not going to work here.
I can go and find you.
Yeah, while they're finding it, Sonny, I just wanted to tell you something funny. Last night, go ahead and find your curvature measurements, post them in the chat there. This guy came in and kind of like that guy's same kind of claim. He's sure it's there. And then he posted an earth curve calculator that said at 20 miles, you'd have 266 feet of drop. So I thought that was great. That was like the best. They were doing the work for us, and we just had to debunk that for them, and that was the end of it. Yeah. Those aren't measurements, but you can find the calculator if you want, Earth Curve Calculator, which gives the predicted curve that's never documented or observed in reality. But let's see what you can come up with there. Who is it we're talking to?
Monturks.
Put that side chat, measurement of curve. We'd love to see.
Yeah, just doing
So if you're providing a Earth Curve calculator or calculations on a chart that show a drop over distance, we know about those. That's not what we're talking about. We need the validation, like Says Who has been asking for, validation that shows actual direct measurement that validates or verifies this claim of a shape. That's a shape claim. That's a positive claim, a geometric claim, as a matter of fact. So we need validation of the geometric claim of the Earth Curve calculator. Go ahead.
So the Earth Curve calculator is based on a value. Now, you can calculate things when you have a value. The problem is where did that value actually come from? That would need to be the measurement of the curvature of the Earth. So we need to see where that value came from. Who measured the curvature of the Earth? Very simple.
Yeah, I like what Lao Tzu said there. A exists. I have to Google A. So yeah, I mean, that's pretty much it. This is kind of the test right here that all of us, we were also sure that the Earth had been verified to be a globe because we were, at least I was. I can't speak for everyone, but I've heard this as a common story for people who eventually realized the globe has no verifiable evidence anywhere. But when you're first looking into it, you're sure. Of course you're sure. It's all been, it's out there. We've seen pictures. My science teacher told me. So yeah, we're sure it's there. And then we go to look and we find there is no verifiable evidence for it anyway. So this is anywhere. So yeah, this is the moment of truth. When you go to look for it, it's not there. And then what your next step is from there. He's still looking. Have you guys had lots of globe believers in here today?
I haven't been in here for too long. We've just been talking with Globe Earth Necros.
Yeah, I saw that. That confused me. Yeah, I guess that guy's gone. Yeah, but he has the same name as the other Necros. Yeah, that was confusing, but I figured it out.
Yeah, got a little confused. Like Necros is arguing for the ball. But they sound different though, right? They do sound different.
Yeah, they sounded totally different. Yeah, that was my first clue. Yep,
Okay.
They sounded totally different.
Necros has our Necros. He's got the heavy Russian thing. Is it Russian? Sounds Russian. Might be something completely different.
And with the planes and with the.
He told me to drop.
So you can just You told me to drive. Rockets, we're not using those anymore. We got rid of rockets. Remember, space is fake, so we can get rid of those. So now we're using airplanes again, right? Okay. So airplanes require air pressure.
You can use the airplane. You can use the airplane.
We're back to air
So
pressure.
whatever. So if the Earth is flat, you shouldn't go back to your start point. You know. So if the Earth is ball, you're gonna end up in the same point that you start from.
Oh yeah, you don't do that. Never happened.
No, it's happened every time, every day.
Nope. Nobody flies around the ball ever.
Everyone flies around.
You've never been in an airplane, have you? You've never actually been in an airplane, have you? You have not. You're a liar. I can tell by the way you answered that.
My English is failing me, bro.
Yeah, right. You've never been in an airplane. Don't lie in here.
So you have been in a plane?
Many times.
I believe what I see, bro.
You didn't see any curve from a plane, that's for sure, because you've never been in a plane.
What about ship? You know. So you cannot deny the ship if you goes by a ship.
Yeah, well, all you got to do is measure the ground, and it's flat.
It's not flat, bro.
Yeah, it's measured that way. Planar surveyors measure it as
So
flat.
how we not reach the limit?
How did you not what?
Reach the limit of the flat plane. You know, the plane
How you
that is flat.
How are you gonna do it? What do you need? What do you need? No, it's not a belief. It's measured flat. It's not a belief. It's measured flat. Measurements.
I don't know what are you saying, bro.
I know you don't understand the difference between knowing something and believing in something. You don't know the difference.
Okay, you know that the Earth is flat.
Yes.
I know it's not.
No, you don't.
No, I do.
You're pretending. You're pretending that you know something. All you have is pretend pictures from the spy agency called NASA.
I'm not dependent on the picture to explain that.
Yes, you are.
I told you if we travel, you in
traveling.
an airplane.
In an airplane. What does you don't go around the ball in an airplane?
What? You're gonna go?
You don't go around the ball in an airplane.
You can go around the ball in an airplane.
Well,
Why not?
Because if the Earth was spinning, you would crash every time you tried to land your plane.
What?
You heard me. If the Earth was spinning, you wouldn't be able to land the plane, would you?
It's different from your perspective.
Whoa.
Yeah.
So you've never been in an airplane. I can tell this already.
I don't know what's your point. What you're trying to prove?
Oh, my point. What am I proving?
You get my idea. Did you get my idea?
I proved all you have is stories.
No, I'm not having a story. I told you, bro, that you have to use airplane to travel around the globe or the flat Earth that you assuming. If you get back to your origin start, that means the Earth is flat. It's not flat.
Yeah, no one's ever done that. You have to stop. You have to stop to get gas.
And you have
to stop to refuel, dude. Dude, you have to stop to refuel. So you have to fly from one airport to another.
No, it's that's a lame excuse, to be honest.
Whoa, so you think you can just get in an airplane and it flies around the ball and then you come back and land at your airport?
I'm trying just to give you a way to prove.
No, there's no way to do that. Yeah, nothing can do that.
Yeah, there is a way. There is a way.
Okay, go ahead. Figure it out. Come up with a good way
I
then.
told you. I already told you. Okay.
No, you
Let
haven't
me
come
give
up
you
with
this.
a way yet.
Let me give you this question. Let me give you this question. How you explain how we see different shape of the moon?
The moon?
Yeah.
What's the moon? What's the moon got to
Sometimes
do with the
we
Earth curving?
You explain to me that because we're living in the flat Earth, we see different shape of the moon. Why?
Because the Earth is flat.
If the Earth flat, we cannot see that, bro. To be honest,
Who said?
it's gonna because it's gonna cover the sun from totally from the moon. You know.
Oh, you think flat Earth sits in a space universe and flies around? Yeah, that's not flat Earth. So you have it all wrong. You have it all wrong. You have it all wrong.
No.
Yeah.
The shadow of,
Yeah. You have it all
the
wrong.
moon.
Yeah. You have it all
No.
wrong. Yeah.
Bro, you know that my English is finished with you right now. So give me a chance to explain stuff.
Okay, you have it all wrong. So correct everything you have wrong, and then we'll move on.
What I have wrong? Okay, correction. Yeah, you can talk. I'm just listening. Yeah.
Yeah, flat Earth is not floating. Flat Earth is not floating in your universe with suns and shit flying around. So you drop that out of your imagination and then go ahead.
How you figured out this?
Because space is fake.
Why?
Because gas pressure requires containment. Can't have gas pressure without a container.
All right. So you believe that?
No, it's not a belief. That's facts.
You know that the gas.
That's science. Actually,
my bad.
You guys like the word science so much. That's science, unless you're a science denier.
Sorry, my bad. That's my English. My English is a little bit bad, so that's why. So you tell me that the air should fill all the space.
What's holding it? What's holding it? What's holding the air around the ball Earth in a vacuum, in a space vacuum?
So there is no space because the air does not fill.
That's right. That's right.
Okay. So you know that there is something not filled, you know?
No. What?
Because you said if there is a space, the air should fill all of it, you know.
Yeah, it should be. There should be nothing left on Earth. It should fly everywhere. Fly all the way to Mars. In your model.
All right. So you tell me that there is something that's not filled with the air.
So we breathe air pressure. Yeah, hold on. We breathe air pressure 14.7 psi normally, about that. Okay. To have that, you need to be inside a container.
So
to have that, you need to be in a container to have that pressure. You need to be inside a pressurized container.
All right. Let me ask you this question. What is that thing that we saw white in the sky?
The clouds?
There is no sun, no moon. There is no sun, no moon. So what is those two things that we see above in the sky?
Birds?
Explain that.
Birds? Clouds?
Clouds?
Clouds? Stars?
So there is stars.
What? Oh, yeah, there's all kinds of stuff in the sky. That's not outer space.
I don't know. How you tell me that there is not? This is not our space.
Because
And,
science,
we can see
science, you're famous science. Unless you're a science denier, science proves that space is fake. Science. Unless you're a science
sometimes,
denier.
bro. That's not,
Are you a science
no,
denier?
it's not. Which theory is proof that the space is not? Which one?
Me, I did. I have a vacuum chamber. I proved it.
All right. So, when are you gonna publish this theory?
Somebody else can do it. I'm not. It's already recorded 3 times on YouTube. Doesn't matter.
All right. So, we can change the subject if you want.
Oh, it doesn't matter to me. It doesn't matter to me. I'm not the believer. I already know Earth is flat.
All right, me too. The same. I already know that the Earth is
Except you can't prove it, and I can prove the Earth is flat. You can't. We can just measure it, and it measures flat.
I can't prove it because my English failed me a lot.
Oh, it's your English? Your English measures the globe? Got it.
No, I can't explain it to you because I struggle a lot with the words to find the.
Don't worry. In every language, your globe theory is fucked up, and I know what you know what that means. You know what that means.
Not in my language. Not in my language. Not in my language, bro. I could explain it to you.
Yeah, let's talk about FE Core. Why was your boys lying out there?
What?
Why were the FE Core guys with the laser test lying out there?
What for?
Why are you asking me?
The FE Core team, they was lying their asses out.
Well, you could better get a hold of them and ask them.
I don't want to ask them, the liars.
So you want to ask somebody who wasn't there?
No, but you guys give it as proof that Earth is measured fleet.
Yeah, because we do that stuff ourselves too. We don't need them.
Where did you do it yourself? Where is the professor
my own laser
triangle measurement?
Why do I have to post my shit for you?
There you go. You didn't do it, huh?
No, I'm not going to post my stuff for you.
Because you didn't do it.
Because I'm not in it to make money and be popular. I have a job to do.
What model is your laser they used in the test?
What model?
There you go. There you go.
Model? Don't you want to know what brand I bought?
Don't you want to stop lying?
So you want me to go turn it on and take a picture of it?
I asked you what model. I think you would know if you had.
No, it's out in my garage and some shit right now. I'd have to go look and flip it over and see what model it is.
When you guys get proof that
you think I know the model of every item in my house?
Calm down, Triangle.
You're crazy.
Yeah, I'm crazy. Calm down, Triangle. But when you guys come in and say we measure the Earth flat,
yeah, it's
you
measured.
Get the FE Core video, the greatest laser test ever made.
You
the greatest
get that one.
laser test ever, and this shit is a bull-faced lie.
So what? Who lied?
Are you following the conversation, man?
Yeah, you said somebody lied. I said who lied?
You guys are using liars' words to prove your shit.
So you're just gonna say that and not answer me?
I just told you. They lied and you're using liars'
about
words.
What? Lied about what?
They lied about their measurements.
Well, what did they get and what did you get?
No, they got something that wasn't what they were saying it was.
What did they get?
I don't know what they get because they didn't show what they get.
So we can just mute you then, since you don't know, but you're going to call people liars, but you don't know why. That's funny.
Man, shut your mouth. I said I don't know what they got because they didn't say what they got. They was lying
so
what they got.
So they didn't lie
They
then.
didn't show what they got. They got
They
some
didn't say-
bullshit.
they didn't
That's
say
what they
anything.
got.
They didn't say anything, so they lied to you.
Yeah, because they claim they got something they didn't. That's called lying,
So
boy.
what did they-
You don't know
what
what
did they
lying is.
What did they claim?
They claimed what they claimed in the video. I'm not describing you a video that you can watch yourself, boy.
I don't need to watch it. I have my own gear. It's all out in my garage,
We
except for my
established
camera.
that's a lie, Professor. We established she was lying your ass too. You don't know the model of the laser.
So you need me to go get my laser, go get my vacuum chamber, and give
Anybody
you the
else
model
want
number
to
of
defend
everything.
that FE core shit?
Nope. Because you can't tell us where anybody's lying.
Light parking can differentiate between a street lamp and the moon. Gunslinger. What do you mean he can differentiate? You're saying the moon he saw in the video was a street lamp. That's what you're saying, Yoder, yeah? You're saying it looks like a come on, man. Come on, you're gonna make me start laughing in here. You're saying that shit was a street lamp, the moon. Yeah, you're saying the moon is a street lamp in the video.
So you didn't even watch the video, did you?
I watched the video, and it ain't no street lamp.
Go back and see if it's a street lamp. Then,
Why are you like trying to? I watched it.
Yoder's
not a
watched
street
it.
lamp.
Yoder watches it. These guys all watch that shit like a hawk.
Bro,
so go back and look again. Go back and look again.
Hoping for the lie.
Go back
You think
and look
I'm lying
again.
because you lying?
Yes. I think
I
you're
ain't
lying
lying,
because
you lying.
you're hoping that people are just lying to you.
No, I'm not hoping that people are lying to me.
Yes, you are.
Why are you like putting situations on me?
Because that's what you're hoping for.
I'm not hoping to people lie to me.
Yes, you do.
Boy.
You're used to it. You
There
like
you
it
go.
when people
There you
lie
go.
to you.
There
Remember?
you
like TV. You like social media. You like when people tell you stories about space. You like when people lie to you.
Okay, Professor. Okay, I see you got on the wrong foot today. You woke up on the wrong side of the bed.
No, I'm just telling you. You seem angry.
You
I'm
seem
not angry.
angry. You're the one. You're the one yapping.
No, listen.
You go talk with the Indian.
When you go to your job, you know, you use your car or what?
Do I use a car? Yeah, because cars don't work on balls. Cars don't work on balls. Cars don't work on balls. You need semi-flat roads for cars to work. They can't be constantly going uphill or constantly going downhill.
Let me talk, please. Let me talk. So you use a car to go your job that's made based on theory that you call a lie. How you explain that?
Whoa! What'd you say?
I said you are using a car to go to your job that are made by theories and laws, physics laws.
No, they're made by engineers, not theories.
You are now
And machinists and shit like that.
based in math and physics that you are not telling it that is wrong and a lie.
What does a car have to do with anything?
It has to do a lot. Because if
So that was pretty weak. I gotta mute this chopper here. Chomper.
So you can't answer me. You can't answer me.
Answer you what?
Left.
What does cars have to do with anything?
It has to do a lot.
Like what?
Every part in the car made by some theories and some calculation stuff, you know? based on those theories that you are now denying.
Made by engineers and machinists. Yes, that's how things are made. Somebody draws up something, they try it, and they go, no, this is not quite right. Let's extend it by a quarter of an inch and then move the hole over here and see if we're getting the right pull there or the right torque we're looking for or something. And then they start doing some math and then they figured it out. But it's not experiments or anything like that. That's not in space. That's just drawing shit in mechanics, dude.
Mechanics based on theories that physics.
No, not on space theories. Not on space, though.
No, space theory. The third law of gravity, based on the third law of gravity.
No.
No, yes.
No.
We measure. Let me give you one small part of the car, for example, the rotor. I don't know how we call it in English. I don't know what is. My English is failing me right now. What is it? Can you hear me?
Yeah, I hear you. Kind of.
Can you tell me what we call the part that's near the wheel?
Hello, everybody.
That are.
I'm here to talk about flat Earth.
Me too.
Yeah, we're still talking about flat Earth. Yeah.
So you guys all think that it's flat as well, yeah?
What?
Oh, he got some LARPers. This is going to be good. Go ahead.
No, I'm genuinely asking, do you guys also think that it's flat?
You go ahead, LARPer. You're up. Yep. Also, you're up. Also.
What do you mean I'm up? I'm asking if you guys all think the same way, like as I do.
I'm actually
as you. Yep. Everybody knows the Earth is flat in the world. They just some people like you think. Yeah, well, some people like you believe you live on a ball. You too.
I just said, do you guys also think? Also, as in, do you guys also think
everybody is a flat? No, everybody is a flat earther. Some of you think you live on a ball, though.
No.
Yeah.
There's a few people believe.
Personally, sorry. Yeah. Personally, I think like the hundreds of years of science, I think is all fake. I think it was all just AI generated.
There's no hundreds of years of science. Science doesn't make
it's all AI
balls.
Generated.
Yeah, science doesn't make globes.
Yeah, exactly. It's AI generated.
Your troll failed.
Yeah, that's what I'm saying. All the science is all AI generated.
That's what I'm saying. So I'm gonna move over to your buddy now. Okay, buddy, you're up.
Oh, where is the moon?
Hello, I'm the buddy. I am the buddy. I'm interested in flat Earth. I haven't got anything against you guys. I'm just interested. I want to hear what you guys got to say. I'm not going to argue.
Oh, nothing to argue about, really.
Yeah, I know. I just want to hear you guys out. I think that's fair.
Oh, sure. Yeah. Earth is flat and stationary.
Yeah, okay. I'll be on mute if you need me.
All right. Who else is up? Ariana.
I believe that the Earth is round.
Whoa, like a pizza?
Thank you.
Around, like
like a coin.
When I was in the high school, we were learning
like a ball. Like a ball,
yeah.
Like a ball.
And they told me that the Earth is around, so I believe in it.
Who told you? Yeah. What if they would have told you it was a pyramid? Then you would have believed them.
If they give me some good arguments for it, maybe.
No, what good arguments did they give you that it's a ball?
The gravitation theory?
No, there's no such thing as that.
Oh well.
Because you say so, or what?
You don't need gravity when you live on flat Earth, do you? Only if you live on a ball flying through space, then you need gravity. Isn't that true?
Does not prove that I cannot fly. Why I cannot fly?
You only need gravity for a ball flying through outer space, don't you?
I said why? Because there is no gravity. Why I cannot fly?
Where are you going to fly to?
I have a question. Sorry, what's the reason for like ships? So we see ships on the ocean, and when they are going from our side, they are firstly we are losing their view of the basis of the ship, and then we are losing their the higher parts of the ship from our
so
view.
easy. It's called refraction. So easy.
So why do we have
So you
it
believe
if the Earth is flat?
Do you know what refraction is?
I know, but why do you think that we have a flat Earth?
What the
Because
fuck?
people are seeking some attention to actually.
What? Can you explain it?
No, that guy's a globe earther trying to explain your question for you.
I get
Do
more.
you know how reflection works?
I got a bit more important question. Can you tell me, please? I'm begging you guys. Like, is my mic better now, or is it better now?
Good.
The first,
Good. Yeah.
yeah,
I can hear it.
it's like.
Second
can
one
you-
is louder.
Okay, yeah. Thank you very much. Yeah, because we're gonna be away from the microphone. Yeah. So yeah.
No, not just. Not so far. So I can hear you. You know. Good. Sorry.
Yes, we both same.
Wow. Unmute him and he's going crazy. That's funny.
It's funny.
Is that all you got left, Daniel?
Me? Yeah.
Yeah. All right,
Yep.
good.
Are you offended by that, or no? Oh, yeah, because I think it's funny. I think it's funny.
I
don't
think it's
mean to
hilarious
offend-
too. I think the
don't
globe
mean
is
to offend
super
anyone.
funny. Yep, I know. I in fact do intend to offend every glober that I talk to.
Why so? Why do you think that anyone cannot believe in what they want to believe?
Well, because you can't believe that you live on a ball if the Earth is measured flat. If you believe you live on a ball when you know it's measured flat, because we've already told you that, then there's something mentally wrong with you. That's why. And I don't want to be associated with mentally disabled people like you.
I think that's one-sided
what's your
because I
argument
have
with
no
the plot?
problem
How
with
you explain
thinking
that?
that the globe is the Earth is globe or the Earth is flat. I don't mind actually, and I think anyone can believe in what they want. Why are you getting offended by that? Like, and you're like so aggressively trying to protect the idea that the Earth is flat, and everyone who thinks in a different way
I'm not
are
protecting
wrong.
it. I'm just telling you it's measured flat. You think that's protecting it somehow.
I find it funny because I think there are like a lot of scientific evidence.
No, there's no science involved. You can't name any one scientific experiment that
I
proves the Earth
understand.
is a ball.
I understand that you think
Then
that it's all
don't
like
use that.
conspiracy
Then don't use that.
theories.
No, you said science, and then you said no. You understand it's not science. So why would you use the word scientific?
No, I understand that it's a science. You actually
It's
find
not.
out that the
What is
Earth
the
is
science?
globe.
What is it? Where's the science involved? What's the experiment they did that proved the Earth is a ball?
Why do they need to make any experiments? Because there's a lot
Because you
of
said
like
it's
proof.
science.
But in order to like prove something, you would need like to have a case, right? To think that it's, for example, it's flat. Why do
No,
you think it's
measured.
flat?
It's because it's measured flat.
Measured flat by what?
Planar surveyors, theodolites,
How do you say it?
lasers. Planar surveyors, theodolites, lasers, high-powered zoom lenses on cameras can also do this stuff now.
Okay, so the moon and all of the stuff is just a kind of a huge conspiracy.
Yeah, we're talking about the Earth. You
No,
guys
I'm
always
just
want to
saying
go to
'cause
the
it's all of
moon.
It's all of the part of the same issue.
No, it's not part of any issue. We don't have
But
any
it's
issue with that
but it's
stuff.
but it's kind of related, right? Because we think, and it's like ordinary thing for us to believe that moon is also like a globe.
Well, you can think
right?
whatever you want about the moon, but we're talking about the Earth.
Hmm. Okay, so why Earth should be anyhow different from other planets?
Why would you think that you're a ball floating in the sky? What makes you think that in the first place? Is it all the flat water around you when you go to the beach? Or is it the fact that everything is flat and level when you're trying to put a pool? You got to level your fucking bottom of the pool so it doesn't collapse. What gives it away that it's a ball? Is it the fact that you need to level roads properly? Is that what gives it away that it's a ball? What gives it away?
Well, what gives it away for me is actually the kind of the videos, kind of the photos that astronauts made.
No,
and, how it looks.
No, we can't use that anymore. We're
sky.
done with NASA. Yeah, we're done with
Okay.
NASA stuff.
So they're all like lying to us, right?
Yes.
Why?
I don't know. Go ask them.
But there should be a reason, like, for them to lie to us, right? If they have any
Maybe
kind of
that's
conspiracy,
maybe that's part of their initiation.
part of their initiation.
Yeah, I don't know.
Okay.
You said there has to be a
Don't you
reason
think
why.
that it's a kind of like super huge conspiracy theory?
No, it's only huge to you because you don't know how to just go outside and understand the Earth is just flat. Flat, stationary, and we're contained. You can't go anywhere. Can't fly to planets. Planets are up in the sky. You don't fly and you don't live on rocks in the sky. That's all on television.
And don't you think you're being kind of aggressive to that?
No.
I didn't even raise my voice to you.
I'm not raising my voice either.
No, you are actually. I'm okay
Not
with
even-
that.
not even
I'm not
close.
offended. I'm
Not even close to raising my voice, dude.
Okay. So Earth is a kind of the experiment by aliens, or what? Why is it? Why does it exist at all?
Well, yeah, aliens are fake. Space aliens, space is fake, so that's out. That's not what flat Earth doesn't exist in your weird universe of round planets. No, we don't float around in a space vacuum. That doesn't exist. That's only in the Globers make up that lie for you, so you guys believe in that.
Solar system also lie.
What solar system? I look up. What do you see when you look up?
I see stars. I see sky.
Okay, I do too.
Okay, that's all right.
That's it.
In telescope, you can see other planets, right?
Not much better. I have better. My camera's better than a lot of telescopes.
Okay.
And that's still fuzzy lights, no matter how you do it.
Okay. So it's just circles, like drowning.
Yep.
And why? So why do they need this kind of circles? What for?
I don't know, because the point is the Earth is flat, not the skylights.
Mm-hmm. But
yeah,
someone made them, right?
I don't know. Yeah, I'm sure something made them. Yeah.
In this kind of the topic, it should be like a kind of the experiment. I think the flat.
No,
Earth,
how are you going to experiment? How do you experiment with the lights in the sky?
I don't know, because I think that's.
Well, then don't say that.
Planets, same as Earth.
Well, how do you experiment with a light up there?
How do I experiment with the light?
Yep. There's a light up in the sky.
Me personally have nothing to do with that.
You're right. Nobody does. Don't try to kid yourself into thinking people actually are scientists that worry about that shit. That's just on TV, movies, when the meteors
does it
are
change?
coming to blow up your house. That's the only time you see those scientists.
What does it change if the Earth is flat or if the Earth is globe? What does it change?
And you don't have to worry about being abducted by aliens. The first thing you brought up.
No, I do think that there are other forms of life in the universe.
Oh, there you go. So space in your universe is fake.
No, of course I cannot prove it because I haven't seen anyone, right?
Right,
But,
of course.
I think that
said
there
it's
is a possibility.
all of your stuff is a belief. We understand that. That's why we're here, because we don't believe anymore.
Do you believe in God?
No, not like you do.
I don't believe in God.
No, see, the flat Earth is stationary, flat, stationary, and it was created and contained because it has air pressure. So creator created it. The end. That's where my story goes. A creator created it. The
Why
end.
not
So
other
you're
forms
gonna
of
ask me more. You're gonna ask me more questions about it after I said the end. That's funny.
All right. No, man, you're good. You're good. It's okay.
Yep, it was created. The end.
So Daniel,
Yeah, sure. What?
if they tell us that over 70% of the surface of the globe is covered in water, can we calculate over a certain distance how much that water should be curving?
I'm not good at maths and I'm not good at all this kind of thing, so it's
No, I didn't ask if you can do it, right? Could someone that's good at math do it? Could it be done?
calculate what exactly.
Did you hear what I asked you?
My English is not perfect. Sometimes I need to double check.
Okay, so if the Earth's a globe, they tell us that over 70% of the surface of the globe is covered in water.
Okay.
Okay, so would we be able to calculate how much that water would be curving over a specific distance? For example, say we have a 20-mile body of water. Could we calculate how much
in
that
terms
water
of the radius, you mean?
in terms of how much the water would be curving over that distance because of the Earth being a globe?
I don't know. Maybe. Probably.
What do you maybe?
I don't know. I don't know, man. That's, as I said, that's not for me.
Do
to
you
ask.
think the water is curving on the globe or it's flat?
Curving.
Yeah, curving.
Curving around the Earth.
Yes.
Well, yeah, that's how the gravitation works.
Right.
But I know
And
it's
then-
a lie. You believe it's a lie, and so I don't think that.
No, it's not about belief. It's not about belief because we can calculate exactly how much it should be curving, and then we can test if it's curving or not.
Okay. So where are
And
you leading to? I don't understand.
Okay, so if it's not curving where it must be curving, how can it be a globe?
I don't know, man. That's too complicated for me to understand.
Really, it should be curving, and then if you test it, it's not curving, and that's too complicated for you to
I
comprehend.
don't know the term curving actually.
Really, bending, curving. You just explained curving around the globe. You just explained to me what it was, so you definitely.
Yeah, but I cannot
bending. Bending. Do you know what bend?
Yeah, and I understand what you're saying, but yeah,
You do understand.
Yeah, I don't understand what are you trying to lead to. So
Okay, so if the water should be bending over a certain distance, let's say 20 miles, there should be 266 feet of bending water over that distance. And if it's not bending, if it's just flat, it has no bending, the Earth couldn't be a globe.
I don't think so.
You don't think that it could be a globe if it's
I
not
don't think
bending?
that it does not bend.
Yeah. So if I said if it's not bending, you haven't tested it though, have you?
No, of course I'm not.
Okay, so if somebody went out and tested it and it's not bending, then it can't be a globe. Let's say we did.
Okay,
let's say we
I'm
did.
fine with that. Fine with that.
Okay,
No
okay. So
problem.
that's been done, and it's not bending.
All right. So the Earth is flat. I understand.
Okay.
As I said, I'm not here
That was
to argue
easy.
a lot. I'm not here to argue.
I'm not
a lot
arguing with you. Look, dude, I'm not arguing with you. I was just asking you like super basic questions.
I'm just wondering about to see what kind of things are you discussing here. What kind of thoughts do you have? So, I'm just wondering why people think the Earth is flat. and
All right. So,
that's it.
Daniel,
That's it.
in the side chat, I got something for you. This is from a NASA IQ test. This is one of the questions. Which of the figures below are not triangles?
That's a geometry question, probably. I'm not good at it. History, that's okay. Maths, no, please.
You're not going to answer this question?
I don't know the answer.
You don't know what a triangle is?
Yeah, I know what a triangle is. For
Do
me,
you know what a triangle is not?
A and
Do you know what a
C.
triangle is not? If you know what a triangle is, do you know what a triangle is not?
A and C looks like triangles to me.
What would not be a triangle then?
Probably D.
So you left out B out of both of those. So what's B? Got
because
something.
B I don't know. Because B I don't know. It's a kind of like.
Well, let's give you a hint.
Not the strict line, right?
Yeah, so the interior of a triangle, for a hint, should equal 180 degrees or it's not a triangle. So,
okay.
And all triangles, three straight lines connected.
Okay.
3 angles equal 180 degrees no matter what.
Okay. Makes sense.
So would B be a triangle?
Then no. But I don't know. Maybe.
No. B's not a triangle.
Okay, B is not a triangle.
Yeah.
We figured it out.
Okay, that's
so
all
A
I
and
need.
A and C are triangles, right? Right. D is also not a triangle.
Which of the figures below are not triangles? It's B and D are not triangles.
Okay.
Okay.
That's what I thought initially.
All right, that's good for now. I don't want to stress you out.
You're not stressing me out at all.
Well, I got some code I have to hit here for a minute, and I'll be right back.
Yeah, so we have all of the tests that I was talking about recorded and able to be seen by people, because you agreed that if we tested the Earth and there's no curvature, then we tested it again and again and again, and all of the tests show that there's no curvature where there should be curvature, then it can't possibly be a globe. What I find interesting is that it's rare that the globe earthers even want to see the tests.
Why so? Why don't they want to see the tests?
Yeah, it's kind of crazy. I don't know.
Me
it's like
personally,
they want to
seeing the tests.
They want to keep living their globe fantasies. So you want to see the tests?
Yeah, you can share it if you have anything. Why not?
Okay.
Again, I'm very open-minded.
Hello?
I don't have any problems with that.
The Earth is flat.
Yeah, it is. Okay, so here's a test in the side chat.
The Earth is round.
I think something can be flat and round at the same time, bro.
Then you might actually be retarded if you think so. I'm just saying. No
Really, I might be retarded when you don't even know how shapes work. But I'm the retarded one. Is a CD round?
So it's a gift. It's not the actual test.
Hold on a second.
You know, like
hold on.
you can
Tenor,
see.
Tenor. Go watch Peppa Pig, Learning Shapes with Peppa Pig on YouTube or something, bro. Go get a basic understanding of what a shape is. Okay, go look up the definition of circle or round, and then come back. All right, so yeah, it's a GIF. Would you prefer it in a different format? Which format counts as?
I would prefer with some explanations, with some like actual.
He's getting there. He's getting there. He is getting there.
You know.
Yeah, he's getting there in a minute.
Yeah, so the camera height's 1 meter off the ground. Okay, and the windmills are out in the ocean at a certain distance. The one on the right is 11.2 miles away.
Where can I check the actual like data about all of that? So
yeah, I've got it all here. I've got it all. This is all just out of a high definition video that goes for an hour and a half, rather than giving you the video.
Okay.
Yeah, so this is done by,
I would better have a video like with all of the like details. You know.
Are you gonna go and watch it?
We are making a video right now.
come
It's
back.
him explaining it to you while we do a slideshow. That's the video. You're in it. Congratulations.
Oh, great. Okay.
There's some distances for you. I'll have to put some stuff up because he has no patience for this, obviously.
Well, I do have patience. Chill.
Okay, so you can see 6 windmills when he zooms in. The one on the right-hand side is 11.2 miles away. So now we're going to go to an Earth curvature calculator, which you could look up yourself if you wanted to go to Google and type in Earth curvature calculator. I've just taken a screenshot from an Earth curvature calculator, and there's a bit of extremely basic math in the side chat there, or some numbers that you need to look at. So from a elevation or a eyesight level of 1 meter, which is 3.5 foot, and a distance to the object of 11.2 miles, which is also 18 kilometers, the distance to the horizon on a globe should be 2.29 miles, or 3.4 kilometers. Do you know what a horizon is?
Yeah, it's the line, right? So
yeah, on a globe, though, right? What happens if something goes beyond the horizon on a globe?
You are not able to see it anymore once it passes the horizon line.
So you shouldn't be able to see any more water beyond the horizon line.
Well, yeah, it should be like that.
Yeah, and then something that's beyond the horizon should be hidden by a certain amount, depending on how high it is.
Yeah, how high and how far. Yeah.
Okay, so if the horizon should be, hold on a second, do you want it in metric or do you want it in miles and feet?
Whatever.
Which one?
Whatever you prefer. Whatever you prefer. I don't know.
Which one do you prefer? I don't care which one.
Metric. Let's do metric.
All right. So here, I'll delete that one and I'll post it in metric.
And what's that calculator again?
Earth curvature calculator. So this one's called Omni Calculator because it's a nice, easy one to use.
Earth curvature
calculator.
Okay.
Yeah, this one's called Omni. It's probably one of the first ones that pops up on Google.
Mm-hmm. Okay,
you could pick any one, but this one. Yeah.
Right.
Okay, so distance to the object 18 kilometers. Eye height level's 1.07 meters. Distance to the horizon is what the calculator is calculating now, based off the globe. So 3.69 miles should be that horizon line.
And that's exactly what's that GIF about, right? So that's related.
Yeah, we're testing for the horizon, which is a byproduct of the Earth curvature if the Earth's a globe.
Mm-hmm. Okay. So your point is that I should not be able to see that thing on the image displayed if the Earth is actually curving. Okay.
Well, the bottom, so you shouldn't be able to see any more water. You should see a horizon at 3.6 miles, kilometers, or whatever it said there. 3.6, yeah, that's right. So yeah, at 3.6, you should have the horizon, where the sky and the ground appear to meet. And then the windmill that you can see let's just focus on one of them. Okay, the one on the right is the furthest one away. It's 18 kilometers away. So the bottom 16 meters should be hidden behind the horizon. But we don't have that horizon where it should be on a globe. In fact, we can see water going way beyond the 18 kilometer windmill. We can even see it going beyond a boat that's out in the distance, beyond the platforms. Okay, so that's red flag number one. Okay, that's something that would have to be there if the Earth were a globe, not being there. And then we don't have the obstruction either. Okay, so let me show you a couple more images in relation to that observation. Okay, so I just want to show you what the windmills look like close up. Okay, so this is just a random photo of the same windmills from close up. When it's low tide, you can see the black paint at the bottom.
Mm-hmm.
And just quickly, this is from the observation. So we can see the black paint at the bottom. So yeah, we can see the whole thing. So there's zero obstruction where they would have to be physically obstructed behind the horizon, behind the curvature of the Earth. That blockage would have to be there if the Earth is a globe. So
Okay.
he did a second observation as well, where he actually lowered the camera height a bit, and once again he could see the whole platforms, and we can even see a boat off in the distance. He tracked that boat that you can see off in the distance with ship tracking radar, and that boat is actually 13.9 miles, which is I think 20 something kilometers out into the ocean, and you shouldn't be able to see that boat at all by many meters. It should be completely hidden behind the curvature of the Earth.
Okay.
Even with the 2 foot, so he lowered his camera down to 60 centimeters, and he did it again. And there's the side by side. One of them's from 1 meter height. One of them's from 60 centimeters height. So, yeah, these are characteristics that would have to be there if the Earth's a globe. They can't not be there. Like, there's not just some random section of water that doesn't curve. And also, this is what happens every single time we go and make observations, whether it be at this location or in America, in California, at the beach, or at a lake, or in Australia or Canada or anywhere else that we go to. We've got so many of these that have been done now. And every single time there's zero curvature present. And we can see not just a little bit further than we should be able to see, we can see orders of magnitude further, like 1,000, 2,000% further, which would mean that the radius of the globe would have to be some huge size, some ridiculous size.
Yeah, that's interesting.
Yeah. Here's another one. This one was done over a longer distance than that one. And this one was done in America at the Great Salt Lake. Great Salt Lake in Utah, it's a good place to do observations because there's not a lot of humidity. It's a very dry environment, and you can see a lot further through the air when you have less less blockages, less humidity. So this one, he sets his camera up at 1.5 meters height, and he's looking over a 34 kilometer stretch of the lake. Here's his camera setup. So he's got his camera just set up right on the edge of the shoreline.
Mm-hmm.
Okay, so there's the camera set up. And here's the shoreline on the other side of the lake. He's got a friend over there just taking some
footage. It's the same channel? Is it the same channel, Dr.
No, this
John
is
D?
it. No. The top one was Dr. John D. Dr. John D he lives in the United Kingdom.
Uh-huh.
And this is this guy's an attorney. His name's I forget what his first name is, but he goes by the username Taboo Conspiracy.
Taboo Conspiracy.
Taboo Conspiracy. I'll post the full videos of both of these just after I post this. Okay, so this is the target in this second image. This is where he's going to be zooming into. This is 34 kilometers away from where he's standing. And here is a top view from Google Maps, just showing you like where he's located, where he set up the camera. So you can see a yellow line there. He's right up that camera set up at the top of the yellow line, and the target shoreline that you can see in the image above, that's where the bottom of the yellow line is. Now, he puts his coordinates in and all of that kind of thing, so he confirms all of that. Now I'll just post, you can just scroll up a little bit, have a look at the observation, because in this one, I'll put the math up on the screen.
Do you believe Google Maps, actually?
Believe Google Maps?
Yeah.
Well, I don't know what you mean by believe it. I mean, it's just a coordinate system that's projected out onto a Web Mercator projection. It's just basically it's based off latitude and longitude.
The photos were made from the satellites, right?
No.
No,
the photos aren't made from satellites.
What is the source of the photos? Where are they coming from?
They have high altitude drones, aircrafts, things like that fly over just like they have the cars that drive around when you click to Street View, and then they have high altitude imagery. Or maybe they have some type of satellites as well, because we can put up different types of satellites, whether it be flat or a globe. Most of the time they're just connected to balloons. So you can get high altitude footage. And then they put it all into a big software program, and then they put all of the data into a Mercator projection map, the big rectangular looking map that most people are used to looking at.
Okay.
So yeah, so the distance is approximately 34 kilometers. I mean, you can go and look at the original surveying records of the actual lake and that kind of thing if you wanted to get it exact. But this is the distance it's claimed to be on a globe.
Okay. All right. I will check this out.
Yeah.
Anything else I should check?
Well, just quickly. So look at the picture of what it looks like on the distant shoreline. And then this is just a screenshot from the footage of where he's zooming in from 34 kilometers away. This one. Notice that we can see the shoreline, and we can also see the White Tower in totality. We can see the whole thing. And then he actually stays there and waits for it to get dark, so he can do the observation again at nighttime. So here's the night shot as well. Once again, we can see that there's no sign of that horizon that should be there. There's no horizon over the entire 21-mile lake. And there's no obstruction at all, where there should be a huge amount of curvature over this distance. So over this distance, there should be about 100 meters of curvature, which is about the size of a skyscraper building, a 30-story skyscraper. So basically, if we're on a globe and there was a 30-story skyscraper on the shoreline on the other side, he should only be able to see the top story of the skyscraper popping out from behind the horizon. But we see zero, like literally zero curvature, zero obstruction. And then during the day, during the night, he does it. And then they actually do a high-powered laser test as well in this same video, where they shoot a laser across the lake at 1.5 meters height, and it hits the target at 1.5 meters height on the other side, which would also be impossible on a globe.
Okay.
So I'll post the videos for you because I said I would.
Okay, so I think I'm gonna go check all of the things that you've sent. Thank you. for materials.
Okay, you're welcome. I haven't sent them yet, but I will.
I think that's already, enough to check. So.
Yeah. Okay. Awesome.
All right. Thank you.
Well, I appreciate you listening.
Yeah, no problem. As I said, I was interested.
Cool. Rodine, you're not server muted anymore.
Thank you.
Yeah, so if anyone has any questions about the observations that I just went over, go ahead. These basically debunk any notion that the Earth could be a globe.